So identifying the period, midline, and amplitude of sine and cosine functions. So we know that normally the period is going to be 2 pi. We've talked about that before. So what I'm gonna show you is if we were inputting the following functions into a graphing device over the domain -2 pi and 2 pi and the range -2 to 2 to complete this table. So I've done it for you down here where you can see the blue one is the y equals 2 sine of x, the green one is the y equals 1/2 sine of x, and then the black one is the traditional sine function. I would recommend doing this yourself just to answer these questions and then coming back to the video just to make sure that you're understanding what midline means, amplitude means, and period. You can throw these. I usually recommend students use Desmos for graphing these types of things. So you'll just go to desmos.com, go to the graphing feature, and you'll type these in, and then there's a little wrench icon that's going to be in the upper right hand corner, and that's when you can make your tick marks be different things. So when you do those tick marks, I would just have the tick marks at every pi over 2 units. And then you can tell it that you want the range for those inputs to be between -2 pi and pi, and then the output to be, so the y values to be between -2 and 2. So that's in that little wrench icon on the upper right hand corner. So if I'm looking at these graphs that I have graphed here, you can see for the regular sine function, which is this black, I'm going to look at, let's first talk about the period. So you can see we've got from here to here, it's not repeating. But then once I get to this part, to at 0 is when it starts repeating again. So there's this same exact cycle. So that period is how long it takes to get to 1 repetition. So if I was looking here, between 0 and 2 pi is the length of that period. So we'd say that the period is 2 pi. I'm going to look just at this red chunk for finding the rest of them. So our midline is going to be right here in the middle, which is at y equals 0. And our amplitude, we can see again, is 1. And again, I'm hoping you guys have done this already and pause the video and filled this out yourself and then come back and we're going to talk about it together. So if y equals 2 sine of x, so that's this blue one, so the midline is still the same and the period is still the same, but what's different is how high up and how low this goes. So that means our amplitude has changed. So that ends up being an amplitude of 2. Here, when you have that 1/2, again, same midline and same period, but now our amplitude has become shorter and it's now 1/2. So again, that amplitude is the distance between the midline and the minimum and maximum values. So we're going to kind of generalize this. If you, so whenever you have something, we're going to call this value in front, we'll call it A. So A sine of x, or even y equals A cosine of x. That A value, the absolute value of it, because again, remember that amplitude is distance, which is always positive. So the absolute value of this number that's in front of the sine or cosine ends up being what the amplitude of the function is. So for example, if we had to graph y equals 3 sine of x, it would be taking this exact same function for sine of x, that black one, but instead our maximum is going to be all the way up here at 3, and our minimum would be all the way down here at -3, and it would look like that. So it's just stretching it vertically, and this kind of goes back to when we learned about stretches and compressions back in Math 111. So let's look at some other things. So we've talked about what this A value is going to be. So before I even put these graphs down, we should know, again, for the original cosine function, it's always y equals 0 for the midline, the amplitude is always 1, and the period is 2 pi. We know here our amplitude, so I don't know what this +1 is going to do, but we do know that's the amplitude. So we know the amplitude is going to be 2, and the amplitude here is going to be 1/2 from what we just learned on the other sheet of the other page. So input the following functions into a graphing device over the domain and this range to complete the table. So I have them down here. This is me doing it in Desmos, so you have a screenshot of it. But again, I really recommend you pause this video right now and do this yourself and answer these questions, just because it will really help you understand these shifts and what's happening here. So If we're looking at 2 cosine of x plus 1, so that's the blue function. So let's see. So now you can see we've got that midline. So again, the midline is the thing in the middle. So that midline, so what's in the middle for that blue function is right here where I'm drawing this purple line. So now I'm no longer having the middle of the function be at 0. Now the graph has shifted up 1. And if you remember learning about shifts up and down, it's when you're adding or subtracting something on the outside of the function. So our midline has now changed to being at y equals 1. Our period, so when does it start repeating itself? So we can see that this is a full cycle starting there and ending here. And then it starts repeating, so that length is from 0 to 2 pi, so our period is still 2 pi. So the period has not changed. When we look at this 1/2 cosine of x plus 1, so let's see what happens when we add 1, if it changes anything to the midline or period. So that's the green one. So you can see that midline is also this plus 1, so y equals 1. And the period, I believe, should still be the same, so let's see. So if I start here, and it ends here. So it looks like, again, that full cycle is 2 pi. So when I add a value to the end, that doesn't do anything to the period, but what it does is it shifts the midline, so it's shifting the graph up or down. So if we have y equals a sine of x plus k or a cosine of x plus k, that k value, so y equals k, is the midline. So just like here, we added 1 and that was the midline. We added 1 and that was the midline. So now let's see what happens if we put a number inside. So we've done a number in front of the function with multiplication. We have added a value to it, to the outside of the function, but now let's see what happens when I put a value and I'm multiplying the input by that. So again, go on Desmos. I want you guys to graph these 3 functions, answer these questions, and then come on back and I'll go through it with you. So if you did, you're going to get these 3 graphs, which are ginormous. So if I'm looking at this again, we know for the original sine function, which is black, we know that the midline is y equals 0, the amplitude is 1, and our period is 2 pi. So let's look at y equals 4 sine of 4x. So that's the blue function. You can see that that midline, so we're halfway between the max and min, is still at y equals 0. Our amplitude is still 1, the distance between the midline and the max and midline and the min. So this doesn't change the midline or the amplitude, but our period looks like it has changed. So 1 full cycle is this, and so the length of that cycle is pi over 2. So now our period has changed. The sine of 1/4 x. So that's the green one. So again, that midline is still at y equals 0. That amplitude is still 1, but now the period, it looks like from 2 pi, negative 2 pi, all the way up to 2 pi, we still don't even have a full cycle. So I'm going to show you guys the formula, and hopefully you were able to extend this out and see that that period ended up being 8 pi, but I'm going to show you where that comes from. So remember back in Math 111, we learned that if you had y equals f of a of x, that was going to be a horizontal compression or a stretch. So if your a value was bigger than 1, it was a compression, which we could see here that when this was bigger than 1, this compressed it. It shrunk the period. It pushed it in. And then if our a value, and so what we would do is, remember with the x values, you always did the opposite. So you would take your x values and multiply them by 1 over a to figure out that. So that compression factor was that 1 over a. And then if your a value was between 0 and 1, then you would multiply again by that 1 over a, which is the same thing as multiplying basically by the reciprocal of that. And that ends up being a horizontal stretch. So what would happen here is this would take this period and I would multiply that, or so that A value is 1/4. So I would take the normal period, which is 2 pi, and I'm going to multiply that by 1/1/4, which is the same thing as multiplying by that reciprocal, which is 4, and that's where that 8 pi comes from. So that probably was confusing, but I'm just showing you guys where this comes from. So there's a formula. So if you have a number, oops, we're going to call this B, a value B inside, so a number that's getting multiplied into your input, or so this works for both the sine and the cosine function. So if you have either of those, so B is going to change the period. So, I cannot spell period. So to figure out the new period, that new period equals 2 pi divided by B, which is the same thing as 2 pi times 1/B. Okay, so this is the formula that you use to find the period. So for example, if I had, let's just say I had y equals the sine of 3x, and I needed to find the period. So that period equals 2 pi divided by b, so that b value is 3, so the period is going to be 2 pi over 3. All right, so input the following functions into a graphing device over the domain -2 pi to 2 pi and the range -1 to 1 to complete the table. So we're going to do the cosine of x minus pi over 2, and then in green I'm going to do y equals the sine of x. So here's what you end up getting, is that if the cosine graph is black and the sine graph is green, this ends up being that sine function. So you can see if I just shift this graph over pi over 2 units horizontally, I'd end up getting the sine function. So again, if you shift the graph over pi over 2 in the horizontal direction, the cosine would become the sine function. So these are actually the same functions. Cosine of x minus pi over 2, so again, that's shifting it pi over 2 to the right. This is going back to transformations from Math 111, is the same thing as y equals the sine of x. So let's kind of summarize these formulas and the different features. So we learned that value, so if you have an a in front of your sine or cosine function, that's the amplitude, and it's the absolute value of that a that makes the amplitude, because again, amplitude is distance. The period is going to be 2 pi divided by b. The midline is y equals k. And then a horizontal shift, and we're going to be talking more about horizontal shifts later on, is going to be that h value. And again, so here this would be that horizontal shift of pi over 2, which is what moves that guy over, everything over pi over 2 units to the right. We'll talk about horizontal shifts more in a later section.